Hi everyone, my name is Neha Mahesh Khanore. I am from Sri Siddheshwar Women's College of Engineering, Solapur. Today I am going to tell about the Linux operating system inode addressing. The Linux inode system is vital for file metadata and addressing. It uniquely identifies every object. This core part of Linux ensures efficient disk file management and access. In Linux, every file is represented by an inode that is index mode. An inode is a data structure that stores metadata about a file but not the file name or its actual data or content. Think of inode as a file ID card. For example, it tells who the file is, what kind of file, where its data is stored, and how it can be accessed. Each file and directory in Unix has a associated inode number which contains important information about the file except its name and actual data. Why inodes are important? Inodes help the operating system manage file efficiently. They contain metadata about files such as size, owner, permission, and modification time. The inode number is uniquely identifies a file rather than the file name. What is an inode? Data structure describes file system objects storing metadata and pointers, not file content. Unique identifier acts as the file serial number within the file system, linking to data blocks. Excluding excludes file name. File name is stored elsewhere. Inodes handles metadata and block addresses. Inode structure metadata stored. For example, file size, owner, permission, timestamps, and block points are included. Size and space modern ext4 inodes uses 256 bytes. Table uses around 1% of disk space. Timestamps access modification and creation time track of file changes. Um, Information stored in inode is in file type, regular file, directory link, etc. File permission like read, write, execute, for example, user group and others. Owner ID, group ID, file size in bytes, timestamp, last access modification and inode change, link count, number of hard links to file, disk block locations, and inode number, unique identifier for the inode index node. Directory entry contains name and inode. Access time. Inode contains access time, size, UID, GID, and file contents. Inode addressing mechanism. Direct pointers. First 12 points straight to data blocks on disk. Indirect pointers. Singly indirect points to the block address with data. Double and triple indirect higher level manage large files via block of pointers. How inode addressing works. Disk block storage. Files stored in disk blocks. Inode list their block numbers. When a file is created, an inode is assigned to it. The file name is stored in the directory which maps to inode number. When you open a file, the system looks up inode to access file information. Hard links share the same inode number while soft links have different inodes. Extent usage. Modern file system uses extend to efficiently track block ranges. Large files, triple indirect pointers enable addressing up to 4 TB files. Inode location and lookup, calculate group and index. Uh, Locate inode by group using inode number and group size formulas. Inode table, linear array storing all inodes for a block group. File lookup, traverse directories to file entry and then load corresponding inode. Limits, file system have fixed maximum inode counts capping in file quantity. Timestamps stored in inodes are a time. A time is used to display the last time the file was accessed. M time is used for last time the file content was modified. C time is used when the last time the inode itself was changed, for example permission. Practical inode operations check inode usage. Use df-i to monitor inode availability on the disk. View inode number. ls-i reveals a file's inode number for identification. Detail the info. Stack command displays inode attributes and metadata. File behavior. Copying creates new node. Moves keeps same inode within the file system. Conclusion. Why inode matter? File system backbone. Inode enables efficient organization and access, seamless file operations, support moving and renaming without disruption, vital for admins, essential knowledge for troubleshooting and system maintenance. When a file is deleted, its inode is freezed. Inode is a fundamental building block of Unix file system. It stores metadata of file, not its name or content. Each file has a unique inode number used internally by the system. Handling shared inodes, tools like ls-i, stack, df-i helps inspect inode info. Inode stores metadata. Each file has unique inode. No file name in inodes. Fixed inode allocations. Soft links have separate inodes. Thank you.